Sir, I can't hear you.
Hello, am I audible now?
Yes, yes.
What is capital G? Universal gravitational constant. Gravitational constant. We discussed it in the last class. Okay, now we have to derive the relation between small g and b. So for that, so consider an object of mass m.
The value of G is to be calculated 6.7 into 10 minus 11.
No, I'll tell you. First, you see the scenario. Consider an object of mass m on the surface of Earth. Right? Then, like this. So suppose you have this is Earth. Capital M is mass of Earth. And you have a small object of mass m kept on the surface of Earth.
Yes.
So by universal law of gravitation, what is the force between small mass and bigger mass of Earth? So that is given by this formula. Let's say the distance between the small object and the center of the Earth is r, the radius of the Earth, right?
Yes.
So by universal law of gravitation, force on the object is by Earth is F is equal to what it will be? G capital M small m upon r square.
Yes.
Right? Because this is the law where r is the distance between the two objects. This mass m is a very small object. We read this as point of. So the distance is radius of Earth. So this is equation 1. Also the weight of the objects is the force
Yes.
that an earth exerts on this object. So what is the weight of the object? Mg, right? Also,
G derives that it is gravitation, right? Yeah, G.
capital G is
Universal gravitation constant.
and its value is 6.67 into 10 raised to minus 11 Newton meter square per kg. This value it will be given to you. You don't have to derive this because this is experimentally calculated. Okay. But what we are trying to do is find out what is the value of acceleration due to gravity of Earth. Right? That's all. So further also force on the object by Earth is equal to weight of object. Okay, force is equal to weight of object. So that is F is equal to mg. So weight of any object is given as mass of the object into acceleration due to gravity by Newton's second law. Right? Because acceleration A is g. And that is the weight of the. So both these forces must be same because they are exerted by Earth only on the object. Okay? So therefore, equating above forces, what do we get? Equation 1 and 2. We get mg is equal to gmm divided by r square. So m and m will be cancelled. Right? So now I am writing here. Therefore, G is equal to yes. What happened? G is small g is equal to capital G into capital M divided by r square. So you see, acceleration due to gravity is independent of the mass of object, right? So now you calculate, substitute the value. Therefore, G is equal to. Now G is capital G is 6.67 into 10 raised to minus 11. Mass of the earth is 6 into 10 raised to 24. Radius of the earth is 6.37, I think. How much is that? Just check. Into 10 raised to 6 to the power 2. So these things are known values. 6.37 is 6.4.
Yes.
Okay, so this is 6.4. So when you, so what is 6 into 24? This is the mass of the earth. And what is radius of the earth? 6,400 kilometers, right? 6,400 kilometers, which when you convert in meter, it will become 6.4 into 10 raised to 6. Okay. So these data, assuming is given to you. So now when you calculate this, you'll get 9.8 meter per second square. So this value of G comes from here. 9.8 into 9.8 meter per second square, which you have been using so far. Take the value of G as 9.8 into 9.8 meter per second square. It comes like this. So important relation between G, small g and capital G.
It is the example of an equation, no?
It is what?
It is the example of an equation. If equation will be given to find the G, so you can do it in this form.
Yes. It is calculation of value of G. Right? Any questions? What is wrong? Okay. Can I erase the right side? Nakshatra, you just give me a thumbs up if I can erase. Okay. Erase the few lines above the diagram. Erase the full right side. Next topic is equations of motion under free fall. This is what we need to write. So what are the equations of motion? We have only total 5 students in this class. There's one reduction. Last time,
If we answer online student, there will be 6.
total 6. 2 online and
4.
why is we need from
No idea.
you're not in the same school? Two of them?
No, it's the same, so but different sections, so then. He's a regular.
So what are the equations of motion? You are familiar with? There are 3. So V is equal to U plus AT. Then S is equal to UT plus half AT square. Then V square is equal to U square plus 2AS. Right? So under free fall, like when the body is dropped from a height, and now it reaches earth surface. Okay. So the height is now the displacement S becomes H. Okay. What is S over here becomes H. And A becomes G. Okay. So G is always in the downward direction.
The A is
Acceleration of the object. But during free fall, what is the acceleration? G. Gravity. Acceleration due to gravity. Gravity is force. Acceleration due to gravity is force. Okay, when we say just gravity, it means force. Which force? Force of the earth on the object. Okay, due to which this object is falling. So this object is falling due to gravity. So gravity is force. During free fall, that force accelerates the object by G. किसी भी ऑब्जेक्ट पे फोर्स लगेगा तो उसमें क्या आएगा एक्सेलरेशन आएगा दैट एक्सेलरेशन इज ड्यूरिंग फ्री फॉल ठीक है तो हाउ डू वी राइट इक्वेशन ऑफ मोशन अंडर फ्री फॉल सो यू कैन राइट a becomes g so v is equal to u plus gt ओके s को तुम h लिख सकते हो h is equal to ut plus gt okay then v square is equal to u square plus 2gh ऐसे कर सकते हो ठीक है खाली s और a चेंज होता है अब इसका साइन ऑफ a साइन कन्वेंशन क्या है साइन ऑफ g is positive during downward motion why क्योंकि ड्यूरिंग डाउनवर्ड मोशन क्या हो रहा है ऑब्जेक्ट का स्पीड बढ़ते जाता है ना ऊपर छोड़ा तो ऊपर क्या था यहाँ पे एट द टॉप u was initial velocity was 0 ठीक है ग्राउंड पे आएगा तो उसका वेलोसिटी इट विल हिट इट विद सम वेलोसिटी v है ना तो अभी ये वेलोसिटी इज ग्रेटर देन u दैट मींस इट इज इंक्रीजिंग इट इज एक्सीलरेटेड so sin of g is positive during downward motion now look at this if the object is now thrown upward right if the object is thrown upward it reaches the maximum height and then it falls back so now it is a retarding motion when it goes up because g is acting downward so sin of g is positive during downward motion sin of g is negative during upward motion of the object. ठीक है? So these are the sign conventions. तो ये तुमको ध्यान रखना होगा कि in free fall, where is the object moving from? It's moving from up to down, downward motion, or upward motion. Upward में retardation. Downward में acceleration. ठीक है? समझ गए? तो that is progress. Clear? अपवर्ड में नेगेटिव ठीक है डाउनवर्ड में पॉजिटिव इसीलिए तो जब तुम ऑब्जेक्ट ऊपर फेंकते हो उसका स्पीड डिक्रीज होता है एक मैक्सिमम हाइट पे पहुंच के 0 होगा फिर वो नीचे पहुंचेगा ठीक है ओके सो वी जस्ट कीप दिस थिंग इन माइंड या okay so next is mass and weight. Next topic is mass and weight. So you can open your volumes. So here the differences are given. First thing, what is mass? Mass is the measure of matter content
And
Okay.
area of
It is the matter
person.
content
The mass of
Of
the
a-
object is the measure of its inertia.
Yes, that's next point. First understand this. So what is matter? The substance is made up of matter. So measure of that matter is mass. Okay. Whereas what is weight?
Uh,
It is the force exerted by Earth on the object.
weight can be zero. No?
Yes. At the center of Earth.
Yes.
Or in the space where there is no reach of gravity.
Yes.
It is the force exerted by Earth on an object. Okay? So weight is force on the object by Earth, whereas mass is the measure of matter content, right? So this is like measure unit is, what is the unit of mass? Kg, kilogram, right?
Yes.
What is the unit of force?
It will be Newton.
Yes. Unit is Newton.
And so mass is a scalar quantity,
Yes,
whereas weight is a vector quantity.
correct. So force is a vector quantity, whereas mass is. So why is scalar? You don't need direction
Yes.
to describe mass, whereas for force,
Direction.
you have to specify the direction. So this is scalar quantity. So it is a scalar quantity. Whereas weight is vector quantity because it has both magnitude and
Direction.
direction.
Whereas
Okay. What else? How can you measure weight, mass using a beam balance? Whereas weight can be measured using spring balance. Okay. So can be measured using
beam balance.
taraju, है ना? Can be measured using beam balance. Beam balance. Okay, it can be measured using spring balance. So you are familiar with spring balance and beam balance? No. So let me show you on the screen. What do we do here now? Can you see the screen?
Yes.
Okay. We have Chrome in this.
So you need to share this screen and
Yeah. We have Chrome in this. Spring balance. ये कौन से इसमें पहला निकला है? Balancer में balance. Yes. Have you seen this?
I'm in class, our teacher is like it carries like weight, like 2 kg, 3 kg.
Yeah. So
Yeah, it's so much also the same.
1 second, I will just. Nakshatra, are you able to see the screen?
No.
Can you see the screen now?
Yes.
So there is a spring balance. So this one. This one, okay?
Yes.
So the calibration are directly in terms of force, Newton. How many? So when you hang, right? When you hang, so there is a hook. When this hook, when you hang any object, this needle will point at how many Newton force is acting on. Okay, that is spring balance.
Yes.
Now let's understand what is the beam balance. Do they take you to school laboratories for
Yes.
physics practicals?
Yes.
Okay, so this is beam balance, the old, right?
We never went for like physics. Chemistry.
Actually, they provide us space and that we have the spring balance.
Yeah, so this kind of a, you will see in your lab, this kind of a balance. Have they shown you anything like this?
No.
Yes.
Have you seen it? So in the laboratory, this is the beam, this horizontal bar, right? And you have a pointer over here. And this white thing is the center. So when you put the object on one side and the weight on the other, so like here is the slotted weight, 110, and object on the other. Then you have to, keep on adding the weights till this pointer is in the center. Then it is perfectly balanced. So here the unit you will get is kg because that's the mass. Okay, whereas in spring balance you get force.
That's
the
one
force.
1 kg, 2 kg, and they are measure that.
Yes, slotted weights are there.
Yes.
I have
At home, yeah, so it's mostly because it's portable, right? But we can't weigh you with the spring balance. Somebody has to be really strong to weigh it, right? Okay, online student, have you understood this? Okay. So I'll go back to share screen again, I'll remove it. Are you able to see the board?
Yes,
You're able to see the board now?
yes.
ये क्या हो गया? उल्टा हो गया क्या? One second. Are you able to see the board, Akshara? Okay, fine. Ashia, sorry. All right. So mass and weight. So one part of this chapter is over. Now you want me to do numericals, or shall I go to the next part? Thrust and pressure, and then we do numericals at the end. Let me start with the next part, thrust and pressure. Okay. There's one more point in mass and weight. Mass is a constant, it cannot change. Okay. Whereas weight can change from place to place. Same object, mass remains constant anywhere in the universe, right? But its weight may change, right? So write down. Mass is constant for a given object. Weight of object changes from place to place due to change of value of small g. Okay, so acceleration due to gravity is different at different places. On the earth also, it is more at the poles and less at equator. So the same object will weigh more at the poles and it will weigh less at equator. Okay. That's how it is. Now, so if I take an object on moon, right?
Then another point is remaining.
What's that?
So it is mass of an object remains a constant everywhere,
Hmm.
whereas weight varies from place to place.
That's what I've written, point one. I just added these.
Yeah.
Okay. Next, now tell me, will the weight of the object same on moon as it is on Earth? Why? Less, because moon's mass is less than Earth, right? So weight of object on moon is equal to 1/6 of weight of object on Earth. Okay? This can be calculated by the same formula. So what was G? So what was the formula for G? G is equal to Gm upon R square. So you can find G on Earth as Gme by R, and G on moon is equal to G mass of moon divided by radius of moon. Okay. So when you substitute these values, right? So you get this relation. G on moon is equal to G on Earth by 6. So this relation you always remember. So all this data is given in your textbook, right? So when you do all this, and you take the ratio of Gm by Ge, so you will get Gm by G is equal to 1/6. Okay, that's why this. Because mass will be same. So on Earth mass will be m. Yes. So weight of the object on moon is m into Gm. And this will be equal to 1/6 into m into G Earth. This is the relation. Okay. This is all right. So weight on moon is equal to 1/6. W is weight. Okay. So just remember this will be useful in solving numerics. So can weight ever be zero?
Yeah, weight can be zero, but mass can be zero.
Why weight can be zero?
Because like in the no, the space.
Correct. So when when there is no gravity, like in space or
Exactly.
at the center of Earth, the weight of the object will become zero. Okay, but not the mass. Mass will have some value. Yes, so that's enough on mass and weight. Have you written this down? Should I erase mass and weight thing?
Yes, I will.
First. So thrust and pressure. Shall I start?
Yes.
Okay. So thrust is basically perpendicular force acting on any plane surface, right? So what is the example of thrust? Let us say I keep some weight on my hand, right? So this weight will exert force in what direction? Downward. So that means weight is causing thrust on the surface. Got it? Right up. Thrust is the perpendicular or normal force exerted by a body on the surface it is kept or on the surface. Okay, for example, weight of the object exerts thrust on the surface it is kept. Yes. Okay, so there is a object kept here. It will exert weight downwards, right? Let's say this is a table surface. So object will exert thrust. And what is pressure? This pressure. Pressure is thrust exerted per unit area, right? Now let's define pressure. It is defined as thrust exerted per unit area. And that is pressure applied. Like if I sit on the table, force is applied on the table. So I am exerting, applying force on the surface of the table. I means my weight. So pressure is equal to thrust upon area. There is first one. Okay. So what is the unit of pressure? Unit of pressure is unit of thrust upon unit of area. Now what is thrust? It's a force. So unit of force is Newton and unit of area is meters. Newton per meter square. Okay. Meter square. So unit of pressure is Newton per meter square. Okay. This is also called Pascal.
That's what it's called.
Also called
That's
Pascal. Pascal is the name of the scientist. So when you write the full name, you write it in lower cases. Symbol is E. Okay. Now next we have to learn about pressure in fluids. So pressure in fluids. This is the next one. Fluid. So what is fluid? Liquid and gases. So fluids are substances that can flow, right? Substances that can flow. Okay, that is liquid and gases. So liquids and gases are fluids, right?
Yes, sir.
Solid is different. Solid cannot flow. Only is semi-liquid or semi-solid, whatever. It is between liquid and solid. So now, let us understand pressure inside fluids. So for that, consider a vessel consisting of some liquid. Right. Okay. So now let's consider some points. Right. Let's call it P1, P2, P3 and P4. So we have 4 points, right?
Yes, sir.
Yes. Yes, that's all. So now this is called depth as you go down, right? So this is called depth. So depth is indicated by H, height or depth, right? So from where the depth is measured from the free surface of liquid. Okay, depth is always measured from free surface of liquid. See, so this is the free surface of liquid. Okay, free surface of liquid. And this is the base of the vessel. Right. So there are certain rules, right? So what is the first thing? At any point inside the liquid, pressure increases with depth. As the depth increases, so where will be the pressure maximum? At point P4 or at the base. Among the shown points, it is maximum at P4, right? So therefore, P4 is greater than P3 is greater than P2, okay, and P1. Okay, it will be greater because P4 is at a greater depth with respect to all other points. Right? Second. So in the same horizontal plane, pressure will be same at all points, right? Because the depth is same.
Yes,
Pressure only increases with depth. So if P1, P2, the depth is same,
same.
right? So pressure is same at all points. At same depth. That is P1 is equal to P2. If you take any other point at the same depth, pressure will be same. Okay. So if a liquid is replaced with a liquid of higher density or a different density, then pressure at the same point will now be different. Okay. If liquid is replaced with of different density. So different density. Then pressure at the same depth pressure will be different. So it will rise if the new liquid has higher density than the old liquid, or it will reduce if the new density of the new liquid is less than the previous. Okay. Then fourth point. Should I erase this? Can I erase this?
Yes, sir. All done. Sir, all done. The whole project. And then we was on one.
Now fourth point. What is the fourth point? pressure at any point in the liquid, any point in the liquid acts in all directions. Okay? Meaning what? Suppose we consider this point. So at this, let's say I take any point, okay? So pressure acts in this direction, all directions. It exerts equal pressure in all directions. So therefore it has no fixed direction. So can pressure be called as vector quantity? Yes or no?
Yes, yes.
Why?
The direction.
All directions means which direction it has? No specific direction. Can we call it vector then? No. Vector should have a well-defined direction at a point. Okay? So it is a scalar quantity. Hence, it has no fixed direction. Therefore, is a scalar quantity. The pressure is a scalar quantity. Now, in case of solid, does it exert lateral pressure sideways?
Maybe that's
Like
it.
if I have a solid like this, it only exerts pressure at the base in the downward direction. If you touch it, do you feel any pressure?
Yes.
You feel any pressure?
No.
See, what I mean to say is, now look here. If I drill a hole here, hole. So will water gush out from here? If you try to block it with your thumb, will there be pressure experienced by your thumb? Right? Because you are obstructing the flow. So liquid can exert lateral pressure sideways because it acts in all directions. Solid, in case of solid, it exerts only the pressure in the downward direction. But liquid behaves differently. It exerts pressure in all directions at a point. Got it? So this means it's just an explanation. This point itself covers it. So the pressure in liquid is in all directions, not just like solid, which is downwards. Okay. So all the points understood, all the 4 points, I think you have covered. Okay. So the formula for pressure inside the liquid is given as P is equal to H rho G. Okay. So if you know H, if you know density of the liquid, rho is the where H is depth of liquid. Time over.
Yes.
Rho is density of liquid. And G is acceleration due to gravity. Okay, so this is how pressure is calculated inside liquid. But you don't have the to derive this formula, just remember. Rho, it's called rho. Just a symbol. It's a Greek letter. It's a Greek letter and rho. Alpha, beta, gamma. So that's English symbols we are short of it. So in physics we need so many symbols to represent different conditions. So in this chapter, we are using this symbol for density.
Yes, I understand.
In electricity, we use it for some other purpose.
Understood.
That's not in line.
Thank you, sir.
Thank you very much. I'll see you in the next class. You have another lecture? You have another lecture?
Yes, ma'am.
Maths.
Maths. MBBS का फुल फॉर्म बोलो MBBS का फुल फॉर्म बोलो क्या मेंटल बैलेंस सपोर्ट मेंटल बैलेंस I wonder if this is God of the President. What? God of the